that with the figure that is mentioned in Bible. Now, this diagram is very important. Most of the cardiac physiology book, this diagram is broad. This is called the volume pressure diagram. Volume pressure diagram. Let us discuss this diagram more. That makes it a little difficult. I wanted to teach you heart failure. At the end of diastole, you are talking about the resting system. At the end of diastole, how much blood is left? 120. Sorry? At the end of diastole, 120.
Yeah.
At the end of systole, 50. This is called ejection fraction. This is called ejection fraction.
What is the use of this?
What is the use of it? When you are talking about cardiac contractility, means force of contraction. When you are talking about cardiac contractility, you should have an index to compare cardiac contractility in different states. For example, at rest, at strenuous exercise, at health, at disease.
You mean EKG?
No, I'm not talking about the EKG.
No.
This is actually taken from echocardiography.
Okay.
Echocardiography. I want to see, for example, her heart is healthy or not.
We use an index.
An index, which can be
Used to compare.
can be calculated, can be reached easily, without any harm to the person. There is a technique which is called echocardiography, using ultrasound to take this index, ejection fraction. Via echocardiography, you can calculate end diastolic volume, end systolic volume, and by using this fraction, you calculate the ejection fraction.
Doctor, please can you write the name of the
Echocardiography.
Echocardiography, yeah. Using ultrasound waves, there is a probe. Using a jelly on the probe and put it over the heart. Very easy. And measure this index, ejection fraction. 120 minus 50 over 120 times 100. How much would be the normal ejection fraction? 70 over 120.
58.
58?
Yes.
Are you sure?
70 divided by 120.
7 divided by 12.
I'm not sure. That will be more than this.
58.3 years.
7.
You can use calculator. You can use calculator.
The normal ejection fraction at rest is around, but with forceful contraction, you can decrease the amount of blood that is left at the end of systole. How much is left? 50. You can reduce it up to 10 to 20. And you can also increase end diastolic volume. The end diastolic volume is 120. You can reach it.
By echocardiography, what do you figure out? Like,
We can figure out, you see,
does it catch the beat or the
no,
volume?
no, listen to me, listen to me. See, this is the beating heart. You can freeze it at diastole. See, this is the left ventricle. The echocardiography has two cursors. Put one cursor here. Put one cursor here and measure the dimension of the left ventricle. From the dimension, you can calculate the volume. End diastolic volume, and then when the left ventricle is contracted, at the end systolic, again you can measure the volume. End diastolic, end systolic, end diastolic.
But it will be of the ventricle, this not the
No,
atrium.
you can also see the atrium. Now you are measuring.
Like if we have to do an echocardiography, we do it like first in the ventricle, then in the atrium, or for the full heart.
For the full heart, you can also make a good picture from the full heart. You can see the contractility, which part of the left ventricle can contract effectively. Suppose that the septum cannot contract.
Like, do we add the figures then, or just?
Yes. Did you get?
Yes.
Yeah.
Have you ever seen a sonography of a pregnant woman? You can see, for example, you can measure the diameter of the head. You have different diameter from the chin to the head, from here to here. The size of the fetus can be measured via ultrasonography. This is the same method. We can take useful information from the structure of the heart. See, the valves are open and closed, open and closed. You can see if the function of the valves are intact or not.
Like the echo means sound, kind of.
Echo means
but
sound.
does it catch the sound and then
Yes,
calculate the?
exactly. You actually use the sound waves. Ultrasound means with high frequency and speed. So you can increase this index via strenuous exercise. You see, you can increase end diastolic volume, increase the venous return by squeezing them. More blood is coming to the left ventricle. You can reach it 180. This is end diastolic volume. With forceful contraction, the amount of blood that is left into the ventricle will be less.
But 180 is when we are at, when we are not at rest. It is a strenuous.
Yes, it is not at rest. It is at strenuous exercise. So you can see, you can increase that fraction. This fraction actually shows you the contractility. And this ejection fraction is normally used in the clinics to compare the cardiac contractility. We will reach it. Now, we want to discuss the pressure volume curve. This is the pressure. This is the systolic pressure, this is the diastolic. N diastolic volume minus N systolic volume is the amount of blood that leaves the left ventricle. This is called a stroke volume. In Farsi, حجم ضربه‌ای. I don't know what you call it in Arabic. حجم ضربه‌ای is Arabic actually. Means the amount of blood that is going out from the left ventricle in each beat. From physics, you have learned that the work equals to force times distance. Here, when you're talking about the work inside the heart, you know it from physics, huh?
Yeah.
Work equals to force times distance. Here, when we are talking about the work inside the heart, this force is pressure, and the distance is volume. Work is pressure. Am I right?
Yeah.
How? Now we want to see how can we measure the stroke work. A stroke work means that the amount of work that is done for each heartbeat. It is called a stroke work output.
So pressure times
Yes. A stroke work output. If we want to measure the stroke work output, means that the amount of energy that is converted into work. Am I right? The total of energy that is used. Part of it is actually converts into heat. Then you have work. Parts of the energy is converted into heat, and part of it is converted into work. I mean, if we want to measure the work that is done by the heart in each beat, which is called a stroke work output, we should measure the area under the curve of pressure volume. This is okay.
Just to measure what?
To measure the work that is done by the heart, which is called a stroke work output in each beat. A stroke work output. This stroke work output is actually in two forms. Most of this work is done when the blood is moving from low pressure veins to high pressure arteries. You should move the blood from the great veins into the heart and to the arteries. Did you get it? So most of the energy, most of the work that is done by the heart is actually moving the blood from the low pressure veins to high pressure arteries. This is called kinetic work or kinetic energy. Most of the energy that is used is. We have two types of work, kinetic and potential.
Yeah.
Hmm?
Okay.
So we have here, we are talking about the,
Kinetic work.
so part of this work is used to move the blood from low pressure veins into high pressure arteries. This is called pressure volume or external work. This is called external work.
External work is the same as kinetic work?
No, no. No, no.
It's called kinetic.
No, listen. From the low pressure to high pressure. This is called external work. The external work is measured via the area under the curve of pressure volume. This is called external work. Part of the energy is kinetic. Kinetic work or kinetic energy is the energy that is used to accelerate the blood to its velocity of ejection. Accelerate the blood to its velocity of ejection. Einstein formula. Am I right? This is Einstein formula. Mass of blood, velocity of blood.
And you're doing it with this.
Yes, I know. This is the external work, pressure volume. Part of the energy is used to accelerate the blood to its velocity of ejection, which is measured by the Einstein formula. Mass of blood, a square velocity. Most of the energy that is used to make the external work is used for the external work. The amount that is used for the kinetic work is very low, which is negligible at rest. But when there is a stenosis and aortic valve, see, kinetic energy is used to accelerate to the blood to its velocity of ejection. So when the opening is very narrow, this amount of work will be very high and is not negligible when the valve is stenotic.
So only in this case it will be high.
Yes.
But in just
At rest, when
negligible.
there is no stenosis, that would be around 1%, which is negligible. But when the valve is stenotic, that can reach around 50% of the total work, which is not negligible. So, part of the energy, we have talked about the kinetic energy, and part is potential energy. You can see at rest, you are not able to expel the whole blood that is left into the left ventricle. 50 milliliter is left. 50 milliliter is left. If you can expel that, the remaining 50 milliliter, which is called potential energy, here is the potential energy. Which is not normally used.
Valve is closed. So how can we expel?
You cannot expel. If you can expel, you will use this potential energy, which is called potential work. Normally, we are not able to expel this remaining 50 milliliter. This 50 milliliter is called potential energy, which is not normally left the left ventricle.
So in what situation does this get expelled?
Yeah, you can expel it.
Like when?
When?
Yeah.
At a strenuous exercise.
Doctor,
Yes.
I can't hear you from here. Can you repeat?
How much blood is left at the end of systole? 50 milliliter. So at rest, it is always remain in the left ventricle. So if you can eject that extra 50 milliliter, so this is another part of energy, which is called potential energy. This potential energy is not normally used.
In what cases do you use?
Extraneous even in a strenuous exercise, 10 milliliter is left.